Welcome back. In this video, we're going to do example 6.7.4. We're given vector u, vector v, and vector w, and first we're asked to use a determinant to calculate the triple scalar product of them. And so we know that the triple scalar product, u dotted with v cross w, is the determinant of the matrix with those vector components in that order put in the matrix as rows. And so we've got a 3 by 3 here. Let's do cofactor expansion. We'll do cofactor expansion across row 1. And so we've got plus, minus, and it actually doesn't matter, but we have a plus there. And so that means we're going to have 2 times, and we'll use the minor then when we remove the 2. And so 0, 3, 1, minus 2. 0, 3, 1, minus 2. Minus 1 times the minor, and now we'll remove the row and column of the 1. So minus 1, 3, 1, minus 2. So minus 1, 3, 1, minus 2, and then lastly plus 0. So we get here 2 times, and we have 0 minus 3, minus 1 times 2 minus 3, which gives us minus 6, and then minus 1 minus 6 plus 1 is minus 5. So that's part A. There is the triple scalar product evaluated as a determinant. Now, the second part, B, asks us to calculate this expression, the value of this expression, 2 ways. The first way is how we would have done it in the chapter on vector algebra. So we're going to use the properties of vector algebra, and then we're going to use properties of determinants as our second method. So let us go here and expand. We're going to use the properties of the cross product. And the cross product, remember, we can distribute over this cross product, and so that is going to give us u plus 2v dotted with, and we'll distribute here 3v cross 3w cross v, and then plus w cross w minus 3u cross v, and then minus u cross w. Now, one of these is nice. The vector cross itself gives us the 0 vector. And then let's take a quick look. We've got v, w, and v, u and v, and u and w, so nothing can be simplified more within that bracket. And so we're going to distribute the dot product. We'll distribute the dot product onto each one of these, and the same thing with the 2v. So we're going to get 3 u dotted with w cross v, and then minus 3u dotted with u cross v, and minus u dotted with u cross w. So that's the u distributed, and now we'll distribute the 2v. So I'll go down on the next line. I'm running out of space here a little bit. So this is plus 2 times 3 is 6, v dotted with w cross v, and then I have minus 6v dotted with u cross v, and lastly I have minus 2v dotted with u cross w. So a lot of these are 0. Remember, whenever any 2 of the entries of the triple scalar product are the same, you'll get 0 because the cross product is perpendicular to each of its components. And so this entry here, I've got 2 u's, that will give me scalar 0. And here I also have 2 u's, and so that will also give me 0. I've got 2 v's here, that's giving me a 0. 2 v's, that's giving me a 0, and so we're left with these 2 products. Now we know u dotted with v cross w from the previous example, so we want them in neither of those orders, and so let's interchange. We want u, v, and w, so this one will make one interchange, and so we'll get minus 3 u dotted with v cross w, and then this, what do we need to do? We've got the w in space in the place, so we'll interchange those, so that is plus 2 u dotted with v cross w. So I've made an interchange in each term. Now this, right, these are like terms, u dotted with v cross w. I can add them together, so minus 3 plus 2 gives me minus u dotted with v cross w, that is the value of minus 5 that we had from part A, and minus 5 gives me 5. So there, using the properties of vector algebra is the value of this expression. Now we're going to do the exact same thing by using determinants. So let's go over here. We can write this as, so this whole expression is a triple scalar product. It's this vector dotted with that vector crossed with that vector. So I can put this as row 1, this as row 2, and this as row 3 in a determinant. So what we have over here is the determinant of u plus 2v, and remember we're using this as a shorthand rather than writing out all the components. We have w minus u, and lastly we've got 3v plus w. So we want to use row reduction now to transform this back up into the triple scalar product that we know. Remember, we know u dotted with v cross w is equal to minus 5. If I use the determinant notation, u, v, and w as rows, that determinant is minus 5. So I want to row reduce this so that it looks like that whose value I know. So if we do a step here, we're going to do row 2 minus row 3, and subtracting rows does not change the value of the determinant. So row 2 minus row 3 will give me, so your row 1 stays the same. Row 2 minus row 3, so w's are going to cancel out. I'm going to get minus u minus 3v. So minus u minus 3v. And then the last row has not changed, so 3v plus w. Now, we are going to add the first two rows together to cancel out those two u's. So if I do row 1 plus row 2, then again, that operation doesn't change the value of the determinant. So if I add these two together, the u's are going to cancel out, and I'll have 2v minus 3v, I will get minus v. Minus v, and then I have minus u minus 3v, and 3v plus w. Now this is nice, I can use this v to cancel out the two v's below it, and so I'm going to say, I'm going to do two operations at once, neither of which will change the value of the determinant. So we'll do row 2 minus 3 row 1, and we'll also do row 3 plus 3 row 1. Doing those will, so the first row will not change. Now, minus 3 minus minus 3, so those v's are going to cancel out. I will be left with minus u, and then lastly 3v minus 3v, I'll be left with w. So I can pull out here, we'll do each of these in a separate operation. We can do minus row 1, that'll bring out the minus sign. We'll get v minus u and w. Then we'll do minus row 2, that'll pull out another minus, so minus minus, we'll turn that into a plus. V, u, and w, and then the last operation that we need to do is an interchange. Remember, we need them in this order to be equal to the triple scalar product, and so we'll do row 1 interchanged with row 2, which an interchange gives us a negative, so negative u, v, and w, which is the cross product, so this is equal to negative the cross product, u dotted with, not the cross product, the triple scalar product, and that is the value that we had before, negative 5, which is 5. So either way you slice it, whether you do the properties of determinants or you do vector algebra, right? It's I'm not sure which one is shorter. They both have their charms, but we get 5 as the expression, as the value of this expression.